Good evening, everyone, and welcome to the Vacuum Transport Seminar. This is our third edition this semester, and we're all very happy to welcome you. We all the organizing organizations, which is Eurotube, Swissloop, the University of Applied Science in Lille, and some Hyperloop, as well as Musera Hyperloop. Today we learn. We have two guest speakers, one from TUM Hyperloop and one from TUM Boring, and we're very happy to welcome them today. As a short information, again, we work with the tool slido.com, where the audience can post a question, and then after every talk we will go through these questions, and the speakers will be asked, and it will be like an interaction round. Now I would like to hand over to Elias from TUM Hyperloop to give a short insight and short introduction of today's speakers. Thank you very much.
All right. Hello, everyone, and welcome also from my side. I hope you guys can understand me. I'm joining from a mall today. Quite a weird situation here, but I hope the audio is good. I'm happy to announce the first speaker today, which is Max from TUM Hyperloop. He's a core part of TUM Hyperloop. He joined almost 3 years ago, actually at the same time when I was joining as well. He started as a business developer, and then after that he has been leading the business case team for over a year, and now he's doing strategic planning, which is also part of the presentation today. Besides that, he's studying management technology at TUM, and he's doing many more things. And for example, also in his private time, he is the most ambitious and successful triathlon athlete. So better not challenge him. Yeah, go ahead, Max. I'm really happy to have you today. I'm looking forward to your presentation.
Yeah, thanks for the warm welcoming words. First of all, I need the permission to share my screen. Otherwise, it will be more podcast here, and I hope no one likes that. Now, I like podcast myself, but not for a presentation of my results. Thanks. I think everybody can see my screen. Otherwise, give me a note. Good. Then I've been here like once before. 1 year ago, like 364 days, I looked it up. So back then was a little bit on the feasibility of Hyperloop in Germany. Today it's a little bit more strategic wise, as Elias introduced me on if the lean startup approach can be used in order to provide good steps for Hyperloop to transform it towards reality. Okay, yeah, perfect. Just checked the chat. First of all, for those people not aware, for TUM Hyperloop, we split our focus into research areas, demonstrator and concept analysis. I myself am working in concept analysis, where we do feasibility studies, ecological impact of a Hyperloop system, all what's really in the future. And demonstrator is more on technical stuff, on actually building stuff. So we are today more on the concept side. So how can we actually transform Hyperloop towards reality? And first of all, why is this important? What's the motivation behind there? The more complex technological innovation is, the more difficult it actually is to transform it towards reality. Like there have been dozens of examples, especially related to transport, where we actually had concepts which were thought out, but actually the transformation towards reality never has happened. So if we illustrate here our way for TUM Hyperloop, we had a first sketch, then we have now the concept, and now there's about the big step towards making the thing a reality. Because otherwise, where are we developing all this? Like, we really want to have there a good outcome. And I personally want to drive once with a Hyperloop and not have it as a concept out there and kind of print out a picture. So what's our idea was here is the lean startup framework can be described in 5 steps. First, validating, finding and prioritizing market opportunities, which means to see which kind of markets can be tackled and how to exploit them. Second, validated learning, so making hypotheses and then rejecting or proving them in order to make design decisions. Third of them is building minimal viable products, which are products with minimal functionalities, though it's in the end the product, how it should look like. Fourth of it is designing business models. So what kind of business models you can actually build for a company in order to bring the product to the market. And if you're actually then on the market, you have to preserve or pivot in the market. So stay in the market where you are, or to change the market when you see in other markets better opportunities. What are the big benefits there? First of all, the Lean Startup Framework actually gives good guidance in order to make this process and allows a very commercialization focused development. In the past, we saw a lot of developments, especially in the transportation sector, where there was commercialization was not the first thing they had in mind. For example, we can take their TransferPit. They developed a very nice product in the end, but nobody wanted to buy it. Of course, you have the case there in China, which actually thriving, but there were much bigger plans. And considering the research and development costs put in, that's a very small output. So the Lean Startup Framework actually can fasten up this commercialization. And the fourth, we come to it later, is like fail fast, fail cheaply. So it should decrease the investment costs, but we come to this in the next slide a bit, how good it can be actually adapted for products like Hyperloop. So methods, quick and dirty here. We did here a single case study onto Hyperloop members and then look their results compared to literature. So using qualitative semi-structured interviews there, and then afterwards inductive coding. And one of these big outcomes here is an adaptation of the Lean Startup Framework towards complex technological innovations. This is a little bit more general because it can now not only be applied for Hyperloop, then other complex technological innovations. To guide you a little bit through what we see here on the right is main of all is the Lean Startup Framework of market opportunities. Then you have the business model canvas and hypothesis testing towards the concept. But what's integrated here is especially those subsystems and their integration to each other. Mainly the Lean Startup Framework in the past was used in the IT industry. So there it's no problem of building MVPs because you build a website. This can be an MVP or a small app, and then you improve it over and over. Though in the end, this doesn't have a lot of costs and therefore has a lot of less subsystems which interact with each other. For the more complex technology innovation gets, the more far apart we are from this original framework. So what you can see here as well is the connections towards stakeholders in the different steps. So how stakeholders actually play in, and that this fail fast, fail cheaply comes to its limits, actually, this mantra I mentioned before, because each of the subsystems could fail, and therefore we have a fail of the overall system. So should we, if we have the case of Hyperloop, if the levitation system for us fails, should we then stop the development? Probably not. We would improve our levitation system because the rest of the subsystems still are working very finely, and therefore continue the development. Second, the customer development, which is the main measuring factor in the Lean Startup Framework, is not very sufficient for complex development, because the customer can only give you feedback on the things he sees. For example, same case with levitation system, the customer will only tell you, it was a very comfortable ride or it was a very uncomfortable ride. He won't tell you much more because you don't know how much other subsystems are related on the underlayers. And so therefore it's not a very good, like in the end, it can be a measuring factor, but like not for designing the product actually. And we see these high costs I mentioned before for each of these iterations. So as you can see here on the right, we therefore will have a refine, design, simulate circle in our building phase of the MVPs, which means we do much more virtual building of MVPs than actually building them. So in order to decrease investment costs overall in development. Next, one of the outcomes is that real options are actually a very good opportunity, though these have to be really considered in the design, which means we build MVPs which with the same underlying concept, which means, for example, same levitation system, same propulsion system, same location of the propulsion and levitation system, and the same guideway, for example, which means we don't optimize for each application case. For example, for passenger transport, it could be an application case for short and longer, long distance travel. For cargo, that means smaller or larger diameter. We always keep the same concept because in order, when we do this, we can increase the validated learning and therefore the maximum outcome we actually have there. So this is definitely one of the results. First of all, this lean startup framework, which we adapted and which can be used, but we have those two mentioned restrictions there of the customer development and the co-creation. Second, we have the real options, which are optimal for increasing the success rates for complex developments. And third of all, we have the minimal viable products, which are inevitable in the development and can provide concrete guidance towards the development. Third, we can provide validated learnings out of these for the whole concept, if the concept is kept throughout the development. And fourth of all, minimal viable products can play a big role in order to prove the economic potential and technological feasibility. Even though this is not important at the start, but if you convince investors or the state, if they're private or public, at one point they want to see a proof. Those minimal viable products are the proof and can show even people which don't have the big technological background why it's a good idea to invest in it, or what kind of value this product can actually bring to them, because the simulation is nice, but actually building something is even nicer there. So what are the big implications for Hyperloop or for Hyperloop in general? So those minimal viable products are inevitable, and so therefore maximizing their value for you is definitely very important. What should be used there are standard parts in order to minimize costs, especially when scaling up. The more standard parts you use, the cheaper you will get. And so therefore, even in the minimal viable product design, this should be considered. Second, when building test tracks, they shouldn't be built on the green field, then building in urban areas in order to then have a application case. Even though, of course, it gives more trouble in actually planning this stuff, you then can use them at a later stage as a minimal viable product of transporting, for example, goods from one factory to the next one. Even though it's not the optimal case, you have a first MVP, which can then show the all long-term effects, for example, the maintenance, the costs of actually building it, the building process. You have there a lot of learnings for the future. Second, to increase the market opportunities, you shouldn't specify your concept on only cargo or only passenger, then make it a little bit adaptable. So this can actually improve the market opportunities, and therefore you have significant performance benefits for the future when you can exploit them. Third, to make use out of those real options as mentioned before. So use the same concept in order to maximize the learnings and increase the transferability of the learnings from one case to the other. And then when the Lean Startup framework is introduced and used, it actually gives a good guidance in this development towards a commercialization of Hyperloop. Good. To conclude, like first of all, Lean Startup framework promises this fast commercialization. Second, we have this substantial investment which MVP required, but we have to do these, otherwise Hyperloop won't become reality. And third of all, those real options can enhance the market opportunities, and we should use it. And one sentence I really want to state here, like we really should keep in mind that innovations have to be made, this change from concept to reality. And like Hyperloop, like it's one of the biggest fears, it won't make this change if you talk to the people. And so therefore, we really should try to make it a reality, and therefore this thesis can give good guidance. Thanks.
All right, cool. Thank you very much, Max. We have a couple of questions again for you. If you're ready, I'm just going to read them out loud and see if you can answer. So the first question we have is, where does the Lean Startup approach not work at university?
Not work in university?
I think it is concerned to the environment. Like the question again is, where does a Lean Startup approach not work at a university?
And at a university, so
yeah. I mean,
okay. Yeah, it could, like the Lean Startup approach can't be used like when you have development from one stage to the other, where you actually have to start with very minor developments, which then build up. But for Hyperloop, in the end, like as we imagine it, like you actually at one point have to build it, and therefore the Lean Startup approach is pretty useful for providing the this guidance of like breaking down the big complex system down towards its limited functionalities, then building it, and therefore testing its different opportunities. Yeah.
And if it can be applied, is it dependent on the project, like the MVP that you want to build, or is it also dependent on the work environment, like if you're a student project, if you're a company, if you're a research program?
No, like I would say it doesn't make a difference. Like, of course, it's a little bit easier if you are like something entrepreneurial, like a small team, because the bigger a company gets, the more complicated and the slower it gets. Though I would say it's applicable for all of them, like from student team towards company, all in between. It only depends if you like focus your entire development towards only developing one product, or if you say, for example, you have one section of the company which works mostly with the Lean Startup framework, the others continue as they do at the moment. This is, from my perspective, an opportunity as well.
Thanks. The next question is, has the Lean Startup approach been used for another transportation system before? If so, which ones? Do you know something about that?
Until now, it was not like it's introduced in 2013, so therefore it's pretty new. It wasn't used before in the development. Not that I know. I haven't read something in literature or found any reference that it has been used before. Though it proves a lot of benefits, like that's the thing. Like actually like this closed loop with the customer, like that you actually talk, like bringing this example of TransRapida again, like you developed a product which is then in the end perfect for what you think your customer wants, but nobody wants to buy it. That's like not very helpful. So we really want to avoid it. So maybe the lean startup approach can be there a good option in order to avoid such developments, which then end up with no benefit for society. Because like innovations, like they should benefit society. And if we invest millions of years within Europe in different projects for towards Hyperloop, we should really wisely see that they actually come to something and we have a benefit as a society as a whole. Yeah.
But it's not state of the art yet for train development or car development, maybe even plane development.
Yes. Yeah. It's not state of the art yet. Like that was the main motivation. We wanted to see if it actually can work, and like there are not a lot of signs why it should not work. Like, of course, you have this cost factor for which, like in software development, it doesn't cost to publish a new version of your website. Like it's, you spend some time and then push it and then you have it on your website. Like, therefore you can start with a very basic website and then increase it over time. Like, that's not that simple if you have to invest a certain development time of 2 years towards a MVP, then you build it for 1 year and put it to the market. Of course, this is not that easy here, but that was the purpose of analyzing it here. Yeah.
Cool. And the last question we have is more similar to the first one. I'm going to read it out loud. Can you use the lean startup approach and enforce it on a university such as Tom? Where does it cross with the framework of learning and research of a research program? So
yeah, like it's mainly like the steps. Like currently we are a research program developing a demonstrator, but like I think it's no secret at one point somehow like the TUM, like as a research program, probably won't build a Hyperloop track of 300 kilometers. Like that's unlikely. So at one point somehow you have to make this step towards commercialization, like everybody knows. Like this thesis and the lean startup framework is more or less the guidance after the first step of completing the research program and then towards the future. Yeah.
Cool. If there are no more questions from the audience, I want to jump in. We have the web questions covered from Fido. Then thank you very much, Mats. Thanks for the talk and the answers to the questions. See you around.
From me. Bye.
All right, and I'm also quite happy to announce the second speaker today. We have Andre here from TUM Boring, and I'm excited for his talk. He is studying mechanical engineering right now in his master's degree. He has been part of TUM Boring for 1 year and roughly 8 months. So he's been part of TUM Boring during the last competition season. He worked in the Cutter sub-team back then, and now is an overall mechanical engineer in the project. Thank you so much for being here, Andre, and I'm excited for your talk. Go ahead.
Hi, yeah, thank you for the introduction. So I'm just going to share my screen here. Can anybody see my screen? All right, I see nods. So let me arrange my desktop for a while. Okay. Yeah, so I suppose everybody can hear me clearly right now. So if in the middle, if in the middle of the presentation. If there is an audio problem, don't hesitate to interrupt me. I will then maybe close my webcam to increase the bandwidth or anything else. Yeah. First of all, I would like to humbly thank the event organizer for inviting TUM Boring for this seminar series on vacuum transportation. Elias has introduced me. My name is Andre, and I'm currently studying in my master's degree on mechanical engineering. And I've been member of TUM Boring since October 2020. On the next 15 minutes, I will be presenting of our innovations in answering Elon's challenge in the tunneling technology. It is basically about what we students did to perform in the 2021 Not a Boring competition. First of all, I would like you to introduce my team. So our team is comprised of 60 plus students from many different backgrounds. Although we have the TUM name embedded in our name, our members are actually students of all three universities in Munich. So it's TUM, HM, and LMU. So we have a mix of theoretically and applied oriented students. We are where we are now because we are supported by the industry. Right on the right-hand side, you can see our sponsors. And of course, the TUM, who financially and technologically support us as well. Here you can see a quote from the TUM's president at the early stage of our formations, of our group formations, which was actually very motivating for us to know. I will then quickly to jump to our timeline that we had in the last competition season. So we start grouping each other in August 2020, and then we had to cope with some recruiting events, and then we have to submit a preliminary design, and then we eventually start building the machine in April 2021. And then we have the chance to test our machines at Ebenhöhe. That was in June 2021. After that, we have to ship the machines. This part takes the longest time. So we have to start shipping it in July. And the competition took place in September 2021. Okay, going from now. What is actually the tunnel boring machine? Tunnel boring machine is actually a machine that can parallelly excavate tunnels and removing materials and then producing tunnel wall on the behind. The tunnel boring technology has been a key solution for urban transport problems for many years. The main concept, like I've just told you, is to simultaneously digging and constructing tunnel underneath the surface without disrupting the peoples that living on the surface. This allows, for example, underground highways and train systems to be constructed without interrupting lives in the skyscrapers, interrupting the rivers, and so on and so on. However, the ongoing development of the new transport technologies, such as the Hyperloops, and I'm pretty sure many of you here attending this seminar is an expert in these fields, or maybe the loop system, or the loop system that's currently being built in Las Vegas. The overall tunnel boring technology needs to be overhauled so that it can be compatible with the new transport technologies. Why? For example, if you want to introduce the loop system, it only makes sense to have just one. It won't make sense to have just one of two tunnels available every 5 years to introduce this system. You will need the transport system would require rapid constructions of tunnel simultaneously everywhere. To support this, the cost of the tunneling should be much lower. So to conclude, the main challenge of the tunnel boring technology right now is speed and cost. To get these two problems into numbers, the tunnel boring cost in Germany for a 10-meter diameter tunnel, let's just take that for example, is between 15 to 20 million euros per kilometer. And the peak digging speed for a TBM is I might remind you, this is the peak digging speed is 1.3 to 1.7 meter per hour. To have a better understanding of this speed, a snail can crawl for about 48 meters per hour. This is where the Elon Musk, the boring company, comes to play. Technology-wise, they plan to tackle those challenges using many innovations that that is already been introduced by them. So let me quickly show you 3 of them. I will tell you. So they plan to build their tunnel boring machines without a start and end pit. This is a breakthrough technology because the tunneling machines can be started only after 2 days after arrival. This is a great breakthrough. Why? Because the current boring technology needs to have a start and end pit, which is very deep and have to be supported with a concrete wall. So you will need to dig first like a hole, vertical hole, and then you will have to put the surrounding concrete walls, the retaining walls surrounding it, and then you can install the machine. And they plan to tackle the speed also using rubber wheel material removal vehicles. So the current technology of the tunnel boring machine uses many transportation system that has to be set up using rail and conveyor belts. So using these small vehicles, they don't need to install the time-consuming conveyor belt setup. And to tackle the costs, the boring company wants to introduce the standardizations of tunnel size. So this way, the tunnel boring machine of the boring company have only 1 TPM for every solutions. This is a breakthrough in cost cutting methods because they have 1 TPM for everything. So they don't need to always develop a new TPM for a new project. Yeah, the company plans to create a new tunnel boring system to be able to go 47 meters per hour. So it's 7 miles per day. I know this sounds challenging, but they are very confident in it. And it now they now has a machine that goes 9.5 meters per hour. So it's certainly much more than what we have in Europe at this moment. And their target tunneling cost is around 6 to 9 million euro per kilometer. So almost half of the tunneling cost that we have right now. Yeah, with those big target gaps to achieve because they are not there where they want yet. So the company decided to hold an international student boring competition and invites the participants to present their innovations to tackle these 2 main challenges. Yeah, in the first iteration of the competition, which is the the Not a Boring Competition 2021, the main challenge is to construct a TPM that bores faster than snail. So here are the parameter of the tunnel. It should be a 30-meter length and in the depth of 1.5 meter and a minimum diameter of 50 centimeter. And the winner is, of course, the fastest TPM that can bore through this length. Yeah, then I would like to introduce to our machines and our solution. Let me play this with you. Can you hear the audio, by the way? No. Okay, that's a pity. So I think we have to go without audio.
Yeah, I think that's the Zoom thing. You have to share the audio when you share the screen.
Sorry, could you just say again?
Oh, sorry, you have to share the audio when you share the screen at the beginning when you select screen sharing.
I see.
For Zoom.
Let me try this again. Advanced sharing option. I have to share sound. Okay. This now should work. Thank you. Nice. Yes. So I will then present our machine. This is our machine. It's basically packed in a container so that it can be easily transported to the States. And also because we are using container, it allows us for easy setup. So we don't need that much time to set the machines on the on-site, on the project sites to start digging. What we do need is we need a starting pit that is no need to be concretely reinforced. So basically we need like a 1 meter depth of a hole so that the container will fit underneath the ground. So it can be quickly installed. Yeah, so because the machine is only designed for the competition, of course, this machine has only 60 centimeter diameter, and the machine is packed inside the machine is packed what we so called the pipe storage, or what we like to call the pipe conveyor. And this is one of our solution because from many of projects that we visit in Munich and in Augsburg and Ingolstadt, we kind of see that using this pipe checking method of a tunnel boring system, the main time consuming element is about the pipe changing. So you will need a crane to hover on the pipe into a position, and then you will need to manually connect all of the electrical tubing, electrical connection and stuff. So this revolver systems enables us to quickly change the pipe into the next sets of pipes. So after the first pipes being finished to be pushed forward, so after these pipes is already a tunnel, this revolver can rotate and put the next tube on the 6-hour position, and then it can be quickly connected and then can be pushed using this checking system. Our checking system consisted of 2 grippers. So the grippers grip the pipe and then to push the pipes forward. Yeah, as you can see here is the details of our machine. Let me go on through one by one of our parts. So we begin with the cutter head, which is the furthermost of all I say the front end of the machine. Our cutter head has, as you can see here, 60% of our cutter head cross sections is optimized for material flow. This is again one of our solution to increase speed compared to the current technology, TPM technology. And we have a cone drum with a screw conveyor, which is very important that we use a screw conveyor because we can dose. We can know precisely how many volumes of material being transported backwards. This way, we can control the volume of the ground material inside this chamber, so that we can prevent it to we can prevent tunnel collapse in this area. So you can imagine the tunnel boring machine is digging a tunnel here, and then the ground is right here. And if the suction effect of this side of these chambers is too much, and then you can end up with suctioning too many material, and then you will have a tunnel collapse. That is one of the dangers of the tunnel boring machine. Yeah, and this cutter head is powered with 4 asynchronous induction motor and has a mechanical bearing over here. And then you can see this is our hollow gear. And then, yeah, these are the ceilings. And next, I will show you the parts in real life. So this is the hollow gears that I showed earlier. It's actually quite beautiful milled parts. And speaking of the cutter wheels that I've mentioned in the slide before, we have 3 different cutter wheels that we could choose depending on the geology of the site that we want to bore in. Due to the fact that the competition is about challenging students to create a machine for all, one machines to be able to dig to many more geology conditions, just like what the boring company is trying to do. So we have to be prepared for any kind of geology, right? So for example, this cutter head right here on our right hand side is prepared to dig into geology of rough stones and rough solid sediments and stuff. And the one in the middle, I would say this is our Formula 1 cutter wheel, because as you can see, the cutting tools here are very edgy and sharpy. It's actually made of a hardened steel that is welded through this frame. And also what's quite cool is these cutting tools are able to be tilted. So they can tilt this way and this way. This enable us to dig with two rotation, this rotation and that rotation, so clockwise and counterclockwise. And as you can see here, we have what we call the stone size limiter. Stone size limiter is a thing so that stones bigger than 8.5 centimeter or maybe 9 centimeter could go inside the tunnel boring machine. So the bigger stones will then get clamped here. And then as the rotational movement of the cutter head, the stone will then be crushed. Yeah, and the left one is our middle cutter head. So it's not optimized for speed and not optimized for power. Going back, we have, like what I've mentioned earlier, our two grippers. This is one of our gripper that is installed right at the front of the container. It's powered by hydraulic. So at the peak power, if these two grippers go simultaneously, it can check up to 1 meganewton of force. Yeah, this frame here is actually what is holding the force of this 1 meganewton checking force. You might be wondering how on earth this container is going to be stay intact or stay in position if you're checking that much force. So as you can see here, this is the connection from the frames. It actually goes out of the containers into another frame that can be hold in position with bunker blocks. Yeah, so we're using friction of the bunker blocks, precisely 32 of them, so that the containers wouldn't move. Going backwards again for our material removal system, as you can see inside of our tubes, we have one conveyor belt. This conveyor belt is for us not a solution, not an innovation yet, and we still think it is a robust solution for us. So because it can transfer 7 kilogram per second. So at this moment at this competition, it suits us very well, but we might think of another new solution for the next coming competitions. I might have said a bit about this. We have a retractable connections here. So what I've said earlier, if the pipe storage is rotating and then we have to attach the next sets of pipe, the connections can be easily done using these retractable racks. So what these racks do is actually it is wheeled. So the racks can be pulled backwards and then connected with the next rack. So this is also a great thing for us because it will definitely speed up the pipe changing progress. Yeah, from the competitions that you might have heard that we luckily won the competition. And I would like from here on just to show you some pictures of our project. So this is when we start the assembly in February. It's in Ebenho in Kahing. This is our steering module being connected. And this is our revolver system. It's actually very big. We have to find a supplier for this. So a couple guys from us have to drive all the way to Frankfurt to find a manufacturer that can and do this for a great deal of money, for a good deal of money. And then in May 2021, we began testing at Ebenho. So it's near Munich, which is actually a great spot. And yeah, the main thing that's very helpful for us as a team is we were able to test the machine first before shipping it to the United States. So that way we already knew which system didn't went well, which system didn't work and we have time to improve it before eventually shipping it to the United States. And of course, because we're shipping the container, we're shipping the tunnel boring machines via freight, via the sea. We have some damages and we have to implement those reparations. We managed to do this reparation in Houston. We are using a site of our supporters of our, one of the company. So we were able to do those reparation on site. These were the hulls that we use to borrow from them. Yeah, and going on is the competition finals in Las Vegas. Our main problem actually in Las Vegas is the heat, because we didn't expect the heat to be that scorching. We have some systems that were not running that well as what we expected because of the heat. Yeah, and after 6 hours, we were able to win the competition. Yeah, from this point, thank you very much for your attention. And I would like to remind maybe the audience here that we have 2 upcoming challenges, 2 upcoming competition, and that we are currently recruiting. So again, thank you very much for your attention, and I hope that I have intrigued your interest, or I might be informative at all. Thank you.
Great, thank you too, Andre. Thank you so much for being here and also sharing the insights. Pretty cool. Before going to the questions, just want to stress again, also congratulations for the win there, and also best of luck for this season. Actually, I mean, it's probably no secret that Hyperloop is going to be cheer for you guys again. Not only because you have Tomb in the name, but also because we're quite well connected. We had Tomb Boring over last autumn, and we invited them for Tech Night and exchanging some technical hot topics. Yeah, now let's continue with the questions. There are quite a few ones actually. I'm just gonna go through and read them out loud again. So first question is, what did your team see as the biggest challenge with today's tunneling? Which part of the challenge did you focus on?
For the general tunneling or for a specific parts, or did I get the questions? So challenge for the general tunneling.
Yep.
Okay. So yeah, our main challenge is because there is no specific faculty in TUM, right, that is specializing in tunnel boring technology. So we have at the beginning no experience at all at this topic, and the main challenge is how to actually do some rapid testing to be actually productive testing for our machines. So we were actually not sure if our design was compatible if it's like compatible with tunnel boring machines, if our design is good with the geology or not, and if our tunnel boring is useful or not, so or can be productive or not. So we have to find sponsors that is actually been working on these fields for many years, and luckily we found some of them, and we have some sessions with them, like info sessions to get our prototype being confirmed, like if it's good enough or if it needs some reparations of if it's not working at all. So yeah, the main problem is the early stages of the team gathering event, because you have so many people, but you don't have members that has experience on tunnel boring.
Yes, and which parts of the challenge did you focus on? For the boring competition, did you focus on special parts or just try to learn every aspect?
So our focus was to improve in the speed. So as you might heard before, most of our innovation is tackling the speed challenge rather than the cost challenge. So the things that we have introduced, like the 60% cut ahead, was specialized for the material removal part, and then that we have this revolver system. So it's kind of clear that our focus lies on the speed. Yes.
The next question is quite direct.
Okay.
It says, what did prevent Tomb Boring in terms of technology from winning the innovation award?
I didn't catch the questions quite good, sorry.
So I'm going to repeat. What did prevent Tomb Boring in terms of technology from winning the innovation award?
Okay. Yeah, because our concept is basically improving the current technology of the tunnel boring machines that's already available in the whole world. So we are going from that and we are improving it step by step. So it is not like a revolution technology that we introduced from scratch, which some of the other teams did. And we are actually using a methods that's already been used and proved in the industry, which is the pipe checking methods. And because we still think that this method is for us the most, how would say, it's the best for us. So we go on from the current technology that we have on market, and then we improved it rather than building from scratch.
Yeah. Yes. Do you want to change that for this season, or do you stick to the most promising concept?
That we still need to. So as you might know, we're still in the recruiting events, and we're still combining the old people and the new people. So we haven't actually been to that state yet. Yeah.
Yeah, sure. Okay. Next question. Do you think that the approach of connecting more and more parts of the tunneling machine is a sustainable way for longer tunnels?
For longer tunnels? So did I get the question correctly? If our machines can be used for longer tunnels?
The question is, if the approach of connecting more and more parts to the tunneling machine, if that is sustainable also for longer tunnels.
Oh, you could modify our machines to be used for longer tunneling projects. For example, we have thought of like connecting second revolver system into our machine, so you can have the loading of the pipes going parallelly to the next system. We could do that, but our current machines is 100% engineered just for the competition, just for the 2021 competition, which is only to dig 30-meter long tunnel without actually having able to dig longer than that. Yeah, but theoretically we could, but then it's some great modifications that could have to be done.
Okay. Since we only have 2 minutes left, the 3 last questions, I'm going to pick the most interesting one, which is probably, which design changes would you make for your tunneling machine when looking at a full-scale tunnel?
Okay, because as I said earlier, the last iteration competition was just only to be able to dig a straight tunnel for a 30-meter. And we have proven that. And so the boring company actually creates a new iteration of competition, which is the next competition in 2023. And they have since then upgraded the competition characteristics. So they want not only for us to dig a 30-meter tunnel, but they want the tunnel to be able to turn left and right. So we have to improve on this since our current tunnel system can only turn up and down. We have to create a new technology or create a new way how to make this happen. So that will include rethinking of some parts of our machines.
And would that also influence the development of a full-scale tunneling machine?
Since our team is only focused on the competition, and again, the next iteration competition is only about, we're talking about 50 to 60 centimeter diameter tunnel. So we haven't really think about making a full-scale tunnel. And because we are a group of students, not a certified engineers, and most of us doesn't have a degree, I wouldn't create a full-scale tunnel where actual people going underneath it, because that couldn't be possible from the insurance and policy and so on and so on.
And also for financing that, I guess.
Correct.
Cost just gonna explode with the increasing diameter.
Correct.
Cool. Yeah, it's 7 sharp. Then that's it from my side. We might have some final words.
Thank you very much to everyone who has participated today. Of course, we are thanking all the listeners at the end. We're also thanking all the hosts and partner organizations, and of course, today's speakers, Maximilian and Andrea. Thank you very much for your talk. Thank you, Elias, for bringing such a strong representation from TU Munich today. And I would just remind everybody up for the next upcoming talks next week. We have MuZero next week with the analysis of potential for using existing rail and highway routes in Europe for high-speed transportation. So that's more on the feasibility study, on the connections where you can actually build a Hyperloop tube. And then we have from TUM Hyperloop again, one presentation that is looking at the permeability measurements of concrete for Hyperloop tubes. So that should also be very interesting, as we see that more and more Hyperloop organizations are switching over to concrete, although, well, but we'll probably hear that next week. Concrete is not so good with when looking at the environmental benefit or the environmental emissions when you can produce everything from renewables. But we'll see that next time probably. And until then, I will just thank everybody, and you can see all the past presentations on YouTube, get a more holistic approach on Hyperloop, and also get all the in-depth information on the technical systems that have been presented already. So that is it for today. See you all next time. Bye.
Thank you. Bye-bye.
Next week. Bye-bye. See you.
Okay.